All right, today we're going to take a trip, but not to some far-off place. Nope, we're going deep inside our own bodies. We're about to explore the most incredible transport system you can imagine, the circulatory system. Think of it as the river of life that's flowing through you right this second. I mean, have you ever really stopped to think about it? Right now, as you're listening, there's a microscopic superhighway just buzzing with traffic inside of you. It's this incredibly complex, high-speed network that's literally keeping you alive. So, what do you say? Let's peel back the layers and see how this whole thing actually works. Time to dive in. Okay, so our journey has to start in that river itself, your blood. And let me tell you, it is so much more than just some red liquid. It's this bustling, super complex fluid, just packed with specialized cells and all sorts of vital stuff. And every single one of its components has a critical job to do. You know, if you took a tiny sample of your blood and spun it really, really fast in a centrifuge, you'd actually see it separate out into two main parts. About 55% of it is this yellowish liquid called plasma. And the other 45%, that's what we call the hematocrit, which is basically all the cells. So what exactly is in that plasma? Well, first off, it's mostly water, like 90%, which is perfect for helping control your body temperature. But dissolved in all that water is this incredible cocktail of everything your body needs to move around. We're talking nutrients like glucose for energy, hormones that act like little chemical messengers, and even the waste products that need to be carried away. Plus, it's got these super important things called plasma proteins. And trust me, we're going to see why those are so crucial a little later on. Okay, now it's time to meet the star of our show, the main character of this whole story. It's the tireless traveler of this river, the erythrocyte, but you probably know it as the red blood cell. And its mission? It's only one of the most important jobs in the entire body, delivering oxygen. And just to give you an idea of the scale we're dealing with, it is just mind-blowing. In one tiny little milliliter of blood, we're talking about the size of a small raindrop here. You have something like 5 billion of these cells, not million, billion, with a B. That alone should tell you just how unbelievably critical these little guys are. So what's their secret? How does each one of these tiny cells actually carry oxygen? Well, it all comes down to a special protein called hemoglobin. You could call it their secret weapon. Each red blood cell is just jam-packed with about 250 million of these hemoglobin molecules. And inside each one is iron, which is what actually grabs onto the oxygen in your lungs. Oh, and by the way, that iron is also what gives blood its classic red color. I mean, these cells are just perfectly designed for the job. It's incredible. They have this unique donut-like shape, a biconcave disc, which gives them a massive surface area to soak up oxygen. They're also super flexible, so they can squeeze through the tiniest, tightest blood vessels. And get this, as they grow up, they actually get rid of their nucleus just to make more room for all that hemoglobin. Now, they only live about 120 days, but no worries. Your body is a manufacturing powerhouse, cranking out 2 to 3 million new ones every single second. Just wow. All right, so our red blood cell is all geared up and ready to go, but it can't go anywhere on its own. It needs a push. And that brings us to the central hub, the engine room of the whole operation, the heart. And we're not talking about a simple pump here. No, this is a seriously sophisticated double pump, and both sides work in perfect rhythm. Okay, let's trace the route. Picture this. Blood that's already dropped off its oxygen comes into the right atrium. From there, boom, it's pushed into the right ventricle. The right ventricle's job? Pump that blood to the lungs to get a fresh tank of oxygen. Then that fresh, oxygen-rich blood comes back into the heart, this time to the left atrium. It gets passed to the powerhouse, the left ventricle, which gives it a huge squeeze and sends it rocketing out to the rest of the body. So here's the really cool part. The heart is basically running 2 different delivery routes at the exact same time. The right side is doing the local route. That's the pulmonary circulation. It's just a quick, low-pressure trip to the lungs and back. But the left side? That's the cross-country route, the systemic circulation. It has to pump blood to every other part of your body, which is a much longer, high-pressure job. And that's exactly why the muscle on the left side of your heart is so much thicker and stronger. It has to be. And with that powerful push from the left ventricle, our little red blood cell is shot out into the highway system. And what a highway it is. We're talking about a vast network of vessels that, if you could stretch them all out, would wrap around the Earth more than twice, 60,000 miles. It's just unbelievable. So this road network has 3 main kinds of streets. First, you've got the arteries. Think of these as the major freeways. They're thick, they're muscular, because they have to handle all that high-pressure blood rushing away from the heart. Those freeways branch off into tiny little capillaries. These are the residential streets, the microscopic alleyways where the real action happens, where oxygen gets dropped off to the tissues. And finally, all that blood collects into the veins, which are like the big collector roads heading back to the heart on a much calmer, lower pressure trip. Okay, but wait a second. This brings up a really interesting puzzle. Once that blood gets all the way down to your feet, how in the world does it get back up to your chest? It's literally fighting against gravity, and most of the push from the heart is gone by then. So what gives? How does the body pull this off? Well, it turns out the body has a few brilliant engineering tricks up its sleeve. For starters, the veins have these awesome little one-way valves. They're like tiny gates that let blood go up, but slam shut so it can't fall back down. Then there's the skeletal muscle pump. Every time you walk or move your legs, your muscles squeeze the veins and literally push the blood upward. And believe it or not, even just breathing helps. The pressure changes in your chest act like a vacuum, helping to pull that blood back up toward the heart. It's just genius. Right, so our red blood cell isn't the only one on this journey. Not by a long shot. This river of life is also home to a dedicated defense force and a super fast emergency repair crew. So it's time to meet the other travelers, the white blood cells and the platelets. Okay, so the white blood cells, they're like the special forces of your immune system. Each one is a specialist, trained for a different kind of threat. You've got neutrophils, they're the frontline soldiers, basically Pac-Man, just gobbling up bacteria. Then you have the lymphocytes, they're the intelligence and assassination unit, B cells make the guided missiles, the antibodies, and T cells go in for direct kills. Monocytes are the heavy-duty cleanup crew, turning into giant macrophages that eat up all the junk. And you have others that are specialized to fight things like parasites or deal with allergic reactions. It's a whole team. And what about that repair crew? That's where platelets come in. Now, these are interesting. They're not even complete cells. They're just tiny little fragments floating around, basically on standby, just waiting for an emergency signal. They are your body's paramedics, the absolute first responders on the scene of an injury, and their entire job is to stop you from bleeding.
So imagine you get a cut. 3 things happen almost instantly. Step 1, the blood vessel itself clamps down, a vascular spasm, to make the hole smaller. Step 2, platelets get the signal, they rush to the site and they get all sticky, forming a quick temporary plug. But that's just the first patch. Step 3 is the real magic. A whole chain reaction kicks off that turns one of those plasma proteins we mentioned, fibrinogen, into these tough, stringy fibers called fibrin. These threads form a strong net, like a mesh, that traps everything and seals the wound up tight.
And just like that, our little red blood cell has done its job. It's dropped off its oxygen, made the long trip back to the heart, and it's getting ready to do the whole thing all over again. See, this isn't a one-and-done kind of trip. It is a constant, non-stop cycle that keeps every single part of you going. And if you want one last fact to just blow your mind, here it is. That entire epic journey we just described, all the way from the heart out to the tip of your toe and all the way back again, our little red blood cell does that whole lap in less than a minute, under 60 seconds. So think about that. This microscopic superhighway is always on, always working, delivering, defending, repairing. It's a system of just breathtaking efficiency, and it's all happening inside you right now, without you even thinking about it. So the question I want to leave you with is, what does all of that, what does this invisible river of life make possible for you? Every breath you take, every move you make, every thought you have, it all starts here.